Frequency distribution. Distribution refers to how the values for a variable are spread out. For example, the distribution for stock return can range anywhere between -100% to positive infinity. Now, frequency, on the other hand, refers to how often each of these values have been observed in the past. So there's two separate things. Distribution talks about all possible values, but then frequency talks about how often these values occur. Now, in order to summarize the data, we often break down the distribution into fixed intervals. Therefore, rather than observing the frequency of each individual value, we can instead get the bigger picture by simply observing the frequency of each range of values. And that's one thing that an analyst has to do, ladies and gentlemen, is that we have to summarize the data, because oftentimes you're going to come across large data banks. And we can't be looking at each individual data point and analyzing that. So what we like to do is we like to develop a bigger picture. And in this case, what we're going to do is we're going to create some intervals and see how many of the observations fall within each interval. So to illustrate, suppose that over the last 10 years, Stock A's annual rates of return have been as follows. So there they are. Now, the data, of course, is random. So when you look at raw data the first time, it's not organized. So the very first thing we're going to do is we're going to rank the data in ascending order. So here's the lowest value, here's the highest value. And the second thing we're going to do is we're going to compute the range from the highest value to the lowest value. So there's the lowest, there's the highest. So if you look at the difference between these two, that gives us a range of 31. Now the next thing is where discretion comes in. So we choose the appropriate number of intervals. So there's 10 data points right there. And so it's up to the analyst to determine how many intervals that they want to summarize the data into. So just for illustration purposes, I picked 4 intervals. And do you see what's going on here? So rather than the analyst looking at each data point and analyzing it individually, we're going to create 4 buckets. Think of these as buckets, and we're going to see how the observations fall within these 4 buckets. Now, if you're picking 4 intervals, they of course have to be of equal width. So you have a range of values that the total range is 31, and you want that spread out over 4 buckets. So therefore, the range of value for each interval will be 7.75. And then in step 5, we construct the interval values beginning with a minimum value, and then we count the number of observations that fall within each interval. So if you look and see what I've done here, so we start with the lowest value. So there it is, just looking at the array data. So our first interval, or our lowest interval, starts from the lowest possible value. So it's -9. But remember, we said each interval would have a width of 7.75. So if you add 7.75 to -9, the first interval ends at -1.25. And then we keep repeating. So the second interval picks up where the first interval left off. And then again, we add 7.75. And then we get this 6.5 figure over there. And then the process just keeps repeating. And let me just finish it. So interval 2 stops there. Interval 3 picks up there. Adds 7.75. Takes all the way to 14.25. Interval 3 stops at 14.25. Interval 4 starts at 14.25. And you add 7.75. And so the highest interval ends at 22. Which of course is the highest value observed in the data set. So now that you've created your 4 buckets, if you will, each one of equal width, we only have to determine how many of the data points lie within each interval. So if you look at -9 to -1.25, so let's look at our arranged data set. So you could see that only these 2 values fall within the first interval right there. And in the second interval, it goes from -1.25 to 6.5. So here we go. Again, you got 2 observations. And then the third interval is from 6.5 to 14.25. So you could see that I have no values that fall within this range. Look at them. I jumped from 2 to 15, so there's nothing fitting between 6.5 and 14.25. And then the final range, 14.25, less than 22. And so you could see that we have all these values right there. And I know I put the less than here, but it really should be less than or equal to 22. That would be a more proper way. But the point is that these four intervals combined will fully account for all the observations. Now, absolute frequency refers to the number of observations in each interval, and choosing the number of intervals is really a judgment call, as we said. However, if too few intervals are chosen, then the summarized data might not say much. So, for example, ladies and gentlemen, if I told you that I'm gonna pick just one interval and it's gonna have a range of 31. Well, that'd be the same thing as just looking at the raw data itself, because if you had one interval with a range of 31, you'd see the same data points without any summarizing. So that's the problem when you pick a very wide range. It results in too few intervals, so it's like you only have one or two buckets to summarize the entire data. Well, that's not really going to tell you all that much information. And it's right there. So for example, if only two intervals are chosen for illustration, we'd have a less clear idea of how the observations were distributed. On the other hand, if too many intervals are chosen, the result may not be summarized enough. For example, if each interval represented a width of 1%, then the summarized data would reveal no more than the raw data itself. And what that means is, if your interval width is just 1%, then you'd have a lot of intervals, right? Because each interval is so small that you need hundreds and hundreds of these buckets, because each bucket is so small. Yeah, but if each bucket is so small, it would probably only contain one or none data points. So again, it wouldn't give you a good idea with respect to any trends in the underlying data.